Similarly, you could easily convince yourself now that if I look at points in the past light cone, I would have the set of all space-time points which are equidistant from O would again be hyperbolas, with asymptotes being these past light cones, these past light rays. And the only difference is that the clocks, if I look at the space-time point which is on this hyperbola at the same spatial location as O, the time tau on this clock would be negative. Okay? So it would be some minus tau times c and 0. However, the space-time interval would still be positive, okay, because it depends on the square of this time, or the difference between this time and the time at O. So again, the space-time interval for between O and every point on this hyperbola in the past light cone is going to be positive. Okay. So again, space-time points in the future or past light cone the space-time interval is positive, and we say that such points are time-like separated from O. Okay, so now let's move on to consider space-time points which are outside of the future light cone and outside of the past light cone. Okay, so let's consider a space-time point located outside of the future and past light cones. So let's say at some location TB, XB. And let's ask, what is the space-time interval or the space-time distance between the point TB, XB and the point at O? So let's call the space-time point B. So in this case, the space-time interval would be equal to XB, oh, sorry. Rather use C times TB since we're measuring time in C times T units, is C times TB whole square minus XB. Again, if we take the locus of all of all space-time points which have the same space-time interval, okay, we would get hyperbolas. So there would be a hyperbola here, with asymptotes being the light cone. I haven't drawn very well, but you can imagine that the asymptote light cone. And in this case, you see that there's a particular point that this hyperbola passes through, which is over here, which is at the same temporal location as O. That is, it also has a time. This coordinates of the space-time point is also at t is equal to 0, but it's some spatial location away. So we'll call that sigma. Okay. So the space-time interval between O and the point B, which is CTB square minus XB square, should also be the same as the space-time interval between O and this point at 0, sigma. So in other words, this should be the same as 0 square minus sigma square, which is equal to minus sigma square. So what this tells us is that points on this hyperbola have a negative space-time interval distance from O. Okay. And if we look at other points, so if we look at another point, let's say over here, okay, this point will, and we look at all points which have the same space-time interval between this point C and the point O, again we would get a hyperbola. Move that point C onto this hyperbola. Again, we would get hyperbolas. Okay, all these hyperbolas have the same asymptotes, which is on the light cone. Okay, and again, it would pass through a point 0, sigma prime. Okay, and again, the spacetime interval would be negative. It would be minus sigma prime square. Okay, so now for all points outside of the light cone, okay, let's write this down. For all points outside the light cone, the space-time interval is negative. And not only is it negative, since all these trajectories pass through a point which is spatially separated from O, but at the same time instant as O, these points are also said to be, or such points are said to be space-like separated. So O is said to be space-like separated from B. Okay, O is said to be space-like separated from B, as well as this point over here. And just for completeness, I should point out that you could also have these hyperbolas in the negative x direction. So you could also have space-like separated points from O, which lie along this hyperbola over here. Okay? So they would pass through a point such as 0, comma minus sigma. But again, the space-time interval would be negative for such points. And finally, we can ask, if we have the point O, which is at 0, 0, what about points, space-time points, which are on the light cone, okay, or on this future light cone, or on the past light cone? So if we take a point over here, remember the trajectory of the light cone is given by this line, ct minus x is equal to 0. So any point on a light beam which is sent out from O, that light beam would pass through this point, let's say over here, if it's sent out on the positive x-axis, and it would pass through a point t comma x. Okay, so let's say this is located at c comma x. And now the space-time interval between this point and O would be ct square minus x square. But since this is a light beam, ct is equal to x, so this would just be 0. So points which are on the light cone are or have exactly 0 space-time distance from O. Okay? And such points are said to be light-like separated from O. So the point here, which we'll call C is light-like separated from O, and that would be true for any point on this light cone, either in the future light cone, or either on the future light cone, or either on the past light cone. They would all have a space-time interval or a space-time distance from O, which is 0. Now, the important thing about these space-time intervals is the space-time interval is something that's agreed upon by all inertial observers, regardless of their labeling of the coordinate systems. Which means all inertial observers agree upon the values of space-time intervals between 2 points. between two space-time points. So the implication of this is that all inertial observers will agree on whether two space-time points are space-like separated, that is, their space-time interval is negative, time-like separated, whether the space-time interval is positive, or light-like separated, that is, whether their space-time interval is 0. So today we have only looked at everything from the perspective of a particular reference frame, S. In the next class, we will see how to represent the observations or the coordinates of an observer or a frame S prime moving with respect to S on the same space-time diagrams.